The James Webb Space Telescope has just transmitted a startling message that has left all NASA scientists in stunned silence. The largest optical telescope in space has been studying various elements of our vast universe for years, uncovering numerous phenomena. However, the most recent image has sent shockwaves through the worlds of science and astronomy. What alarming image has the James Webb Telescope captured? Could it have snapped a photograph of an alien presence in the far reaches of space? Join us as we delve into these chilling new images revealed by the James Webb Telescope, images unlike anything we've seen before. If you're keen on staying updated with the latest news about the universe and its surroundings, be sure to subscribe to our channel, like this video, and activate the notification bell. NASA's $10 billion James Webb Space Telescope, launched by the European Space Agency from French Guiana, reached its new cosmic location. This infrared observatory began offering spectacular views of the cosmos, thrilling both scientists and astronomers alike. As the largest and most advanced space telescope to date, the excitement was palpable when the first Webb-based scientific images were unveiled. However, what they saw almost left them speechless. When the James Webb Space Telescope turned its instruments toward the famous pillars of creation, it captured the renowned gas clouds in stunning detail. These pillars are situated in the Serpens constellation, approximately 7,000 light-years away from Earth. They are part of the Eagle Nebula, large clouds of gas and dust that the Hubble Space Telescope first photographed in 1995. Since that first photograph, the pillars have been celebrated for their extraordinary beauty. The new photograph taken by the James Webb Space Telescope reveals these pillars of creation in even sharper detail. Numerous stars, previously invisible in Hubble's images, are now visible, some having formed only a few 100,000 years ago. This marks a significant breakthrough in science. Though it's still uncertain whether these stars are part of any extraterrestrial constructions, the James Webb Space Telescope also observed the Pandora cluster, delivering another spectacular image. This name draws inspiration from Greek mythology, where Pandora's curiosity led to the release of evil and suffering into the world. In a similar vein, the James Webb Space Telescope focused on a specific area of space called the Pandora cluster, an idea that was first predicted by Albert Einstein in 1915. These new images have left scientists scratching their heads, as they reveal features previously unknown in this area of space. However, this region of space is formally known as Able 2744, part of the Pandora cluster, and showcases a variety of distinct structures. What makes this image remarkable is that, while the region has been studied before, only the central core had been analyzed by the Hubble Space Telescope. This suggests that many important secrets are still hidden in this intriguing region of space. It wasn't until the James Webb Space Telescope aimed its powerful infrared instruments at the Pandora cluster that these details began to emerge. The team used Webb's near-infrared spectrograph and near-infrared camera as part of the deep observation program before the ionization epoch. The team took 4 snapshots, which were then combined into a panoramic image revealing around 5,000 infrared light sources within the Pandora cluster, located about 3.5 billion light-years away. The image struck an impressive balance between depth and breadth, which could drastically shift our understanding of galactic evolution. One highlight of this image is a bright foreground star from the Milky Way, displaying unique diffraction peaks created by Webb's instruments. Bright sources of white light surrounded by a hazy glow also appear, corresponding to distant galaxies within the Pandora cluster. While human-developed technology was essential for observing this galaxy cluster, astronomers also relied on a natural phenomenon proposed by Einstein in his general theory of relativity, published in 1915. In addition to thrilling discoveries, the James Webb Space Telescope has captured strange space phenomena that even scientists can't explain. One such enigma is the mysterious concentric rings observed around a distant star, which astronomers have yet to explain. A citizen scientist posted the image on Twitter, sparking a flurry of responses and discussions within the scientific community. The image showed a star named WR140, surrounded by regular, wave-like circles that gradually faded. What stood out, however, was that these circles weren't perfectly round, they had a somewhat square shape. This resulted in theories about a possible extraterrestrial origin. However, some scientists argued that this could simply be a natural occurrence viewed from a single perspective, as nature sometimes presents extraordinary phenomena that have simple explanations. Still, questions persist. Why do these rings have that particular shape? And why are they so regular? This mystery has troubled many scientists, including Smith, who isn't the only one puzzled by these images. Mark, an interdisciplinary scientist from the JWST Science Working Group and a science advisor to the European Space Agency, explained on Twitter that the image's blue structure is an artifact caused by optical diffraction from the bright star WR140. He also noted that the scene with the red curvature in the image is real and represents a series of shells surrounding WR140 in space. Although NASA is expected to release a statement soon, something about this phenomenon is certain. In general, young stars tend to glow bright blue, and over time, they shift to a more reddish hue as they consume their fuel and cool. Astronomers didn't anticipate seeing red stars in the ancient galaxies featured in the James Webb Space Telescope's observations, nor did they expect to find galaxies much more massive than our own. These red spots, revealed by Webb, appear to be 50 times more massive than expected. According to Joya, the most massive galaxies in this study are estimated to be between 2 and 4 times larger than the Milky Way. This discovery is shocking because galaxies as massive as ours were thought to have formed much later, when the universe was only 3% of its current age. Leah also mentioned that before researchers begin revising cosmological theories to explain how these galaxies formed so soon after the Big Bang, they must ensure that these strange red spots aren't something else. However, even if alternative explanations were proposed, they would require entirely new concepts. For example, stars in the early universe may have emitted light in unique ways due to a lack of heavy elements, which aren't accounted for in our current models. The images showing these massive galaxies were captured by Webb's near-infrared camera as a component of the Cosmic Infrared Evolution Early Release Science program. The team plans to revisit these galaxies and gather spectra from distant points. The spectra will break down the observed light by its composition and wavelength, providing critical information about the chemical and physical properties of the sources. Most importantly, the spectra will allow scientists to precisely measure the distance to these objects, helping to confirm their identity. If we can determine the distance, we can better understand what these objects truly are. These groundbreaking discoveries have raised fundamental questions about the evolution of the universe. If galaxies as massive as the Milky Way existed so early in cosmic history, it suggests that star formation and galaxy assembly occurred at a much faster rate than previously thought. This challenges long-held models of galaxy formation and may require a major revision of astrophysical theories. As scientists analyze the data further, they are looking for alternative explanations. Could these red spots actually be something other than massive galaxies? Some researchers speculate that they could be bright star clusters or even supermassive black holes surrounded by glowing accretion disks. However, if these objects truly are ancient galaxies, they may represent a previously unknown phase of cosmic evolution, one that defies our current understanding of how the first galaxies formed and grew. Meanwhile, the James Webb Space Telescope continues to push the boundaries of human knowledge. It has provided stunning images of exoplanets, revealing details about their atmospheres that were previously impossible to detect. By analyzing the light passing through an exoplanet's atmosphere, scientists can identify its chemical composition, potentially uncovering signs of habitability, or even life. One of Webb's most anticipated missions is the search for biosignatures on exoplanets orbiting within the habitable zones of their stars. By detecting molecules such as water vapor, oxygen, methane, and carbon dioxide, astronomers hope to identify worlds that could support life as we know it. Some exoplanets, such as those in the TRAPPIST-1 system, have already shown promise, and Webb's advanced instruments may soon provide new insights into their atmospheres. Beyond exoplanets, Webb is also shedding light on some of the universe's biggest mysteries, including dark matter and dark energy. These invisible forces shape the cosmos, yet their true nature remains unknown. By studying how light bends around massive objects due to gravitational lensing, Webb is helping scientists map the distribution of dark matter across the universe. Its observations could also reveal more about the expansion of the universe and whether dark energy is changing over time. Despite its early success, the James Webb Space Telescope has only begun its journey. With a mission expected to last at least a decade, it will continue to capture breathtaking images and uncover new cosmic secrets. Every new discovery adds another piece to the puzzle of our universe's history, forcing scientists to reconsider old assumptions and explore new frontiers in astronomy. As we stand on the brink of a new era in space exploration, one thing is clear: the universe is far more complex and mysterious than we ever imagined. With each image and data set transmitted back to Earth, Webb is bringing us closer to answering some of humanity's most profound questions, about our origins, our place in the cosmos, and whether we are truly alone in the vast expanse of space. Early galaxies, another awe-inspiring image. Another awe-inspiring image captured by the James Webb Space Telescope shows the Ghost Galaxy, which appears to spin like a wormhole before our eyes. This image, based on deep space data, highlights the dust lanes of galaxy NGC 628, also known as M74. Previously called the perfect spiral due to its symmetry, the Ghost Galaxy is particularly interesting because it's thought to harbor an intermediate mass black hole at its center. While the Ghost Galaxy has been observed multiple times by other space telescopes, Webb's infrared observations stand out because they reveal cosmic dust in extraordinary detail, enhanced by its unique 18-segment hexagonal mirror and its position in deep space. What are your thoughts on these new discoveries? Let us know in the comments section. Don't forget to like this video if you found it interesting and subscribe to our channel so you don't miss out on more exciting content. Thank you for watching. We'll see you next time. The impact of the James Webb Space Telescope. As we dive deeper into the discoveries made by the James Webb Space Telescope, we begin to realize that each new image, each new observation brings us closer to answering some of the universe's most profound questions. What's even more extraordinary is that these discoveries aren't just about new data points or incredible visuals, they're also reshaping how we view the cosmos. These unprecedented findings challenge what we thought we knew about space, time, and the very formation of galaxies. One fascinating aspect is how Webb's infrared technology is informing our understanding of the invisible parts of space, giving us a clearer picture of previously unseen phenomena. While Hubble and other telescopes have provided breathtaking images in the visible spectrum, Webb's infrared capabilities allow scientists to peer through cosmic dust and gas, unveiling objects that were once hidden from view. The sheer clarity and depth of the images Webb has produced are helping to answer some of astronomy's toughest questions, such as the origins of galaxy formation and the behavior of black holes. Early galaxies, a new perspective. For example, the James Webb Space Telescope has captured galaxies that existed only a few 100 million years after the Big Bang, a period known as the Cosmic Dawn. These galaxies are older and more massive than scientists had expected to find at such an early stage of the universe's existence. The findings challenge existing models of galaxy formation and evolution, suggesting that these early galaxies may have formed much faster and in more diverse ways than previously believed. This has prompted researchers to reconsider our understanding of how galaxies evolve over time. The search for life beyond Earth. In addition to its observations of distant galaxies, Webb has also provided new insights into the atmospheres of exoplanets, opening up a whole new avenue of research in the search for life beyond Earth. By studying the light passing through the atmospheres of exoplanets, astronomers can now detect the presence of gases like methane, carbon dioxide, and even water vapor, which could be potential indicators of habitability. This capability marks a major milestone in the hunt for extraterrestrial life, providing us with tools to better understand the conditions that may support life on planets far beyond our solar system. Unlocking the secrets of dark matter and dark energy. The James Webb Space Telescope also brings us closer to understanding the nature of dark matter and dark energy, two of the most mysterious forces in the universe. While much of the telescope's current work focuses on observable phenomena, its detailed observations could provide important clues that help scientists identify these invisible forces. By examining the way galaxies interact with each other and how light bends in space, Webb could reveal hidden properties of dark matter, which makes up a significant portion of the universe's mass. Similarly, its ability to study the expansion of the universe could help researchers gain a better understanding of dark energy, the force believed to be responsible for the accelerated expansion of the cosmos. The future of space exploration. What makes these discoveries even more significant is that the James Webb Space Telescope is still in the early stages of its mission. We can only imagine the wonders it will continue to reveal as it explores the furthest reaches of space. Scientists are already planning additional observations to deepen our understanding of the galaxies, stars, and exoplanets that Webb has introduced us to. These observations will help refine our models of the universe and potentially rewrite some of the fundamental laws of physics. As we look ahead, we are also reminded of how much more there is to discover. The universe is vast, and our understanding of it is still in its infancy. The James Webb Space Telescope represents a giant leap forward in our investigation of the cosmos. However, it's clear that there's so much more to uncover. The discoveries made so far have only scratched the surface, and with each new image or piece of data, we get closer to answering questions that have baffled scientists for centuries. A testament to human curiosity. The revelations brought to light by the James Webb Space Telescope remind us of the boundless mysteries of the universe, many of which have remained hidden from view, until now. As we continue to explore and learn more, it's essential to remain open-minded and flexible in our thinking. Our current models may not be the final answers, but they are stepping stones toward greater understanding. Webb's groundbreaking work serves as a testament to the progress of human knowledge and our unyielding curiosity about the universe we inhabit. Conclusion. The James Webb Space Telescope has already begun to reshape the field of astronomy in ways we could have only imagined a few years ago. With its unparalleled power and precision, it has opened up new frontiers in our understanding of the universe, from the first galaxies formed after the Big Bang to the detailed study of alien atmospheres. While there are still many mysteries to solve, the discoveries Webb has made so far have set the stage for even more exciting revelations in the future. Stay tuned as the universe continues to unfold before our eyes, and as the James Webb Space Telescope continues to reveal the secrets of the cosmos. The next frontiers. What's ahead for the James Webb Space Telescope? As the James Webb Space Telescope continues its mission, astronomers are preparing for even more groundbreaking observations. While its initial findings have already challenged our understanding of early galaxies, black holes, and exoplanets, Webb is expected to make even deeper discoveries in the coming years. 1. Unraveling the mysteries of the first stars. One of JWST's primary objectives is to detect the first stars that formed after the Big Bang. These stars, known as population 3 stars, are thought to be massive, hot, and composed entirely of hydrogen and helium, as heavier elements had not yet been formed. Scientists have long theorized about their existence, but no direct observations have been made, until now. With Webb's ability to look deeper into space and further back in time than any telescope before it, it may finally provide evidence of these first stars, shedding light on how the early universe evolved. 2. Mapping the evolution of galaxies. Webb has already provided stunning images of distant galaxies, some of which formed just a few 100 million years after the Big Bang. But how did these galaxies grow, merge, and evolve into the structures we see today? Future JWST studies will aim to trace the formation of galactic structures over billions of years. Study how supermassive black holes influence galaxy growth. Examine how star formation rates changed across cosmic history. These observations will help refine our models of galaxy evolution, giving us a clearer picture of how the universe has matured over billions of years. 3. Probing the atmospheres of Earth-like exoplanets. One of the most exciting aspects of Webb's mission is its ability to study the atmospheres of exoplanets, including those in the habitable zones of their stars. Scientists are particularly interested in finding biosignatures, or chemical signs of life, such as oxygen, O, and ozone, O, possible indicators of biological activity. Methane, CH, and carbon dioxide, CO, could hint at active biological or geological processes. Water vapor, HO, suggests the presence of liquid water, a key ingredient for life. By analyzing how light interacts with these atmospheres, Webb could identify planets that have conditions suitable for life, bringing us one step closer to answering the question, are we alone in the universe? 4. Examining the role of dark matter in cosmic structures. Dark matter remains one of the biggest unsolved mysteries in physics. Though it makes up about 85% of the universe's total mass, it cannot be directly observed. It only reveals itself through its gravitational effects on galaxies and light. Webb will help scientists study gravitational lensing, a phenomenon where light from distant galaxies is bent by massive objects in its path. By studying how light is distorted, astronomers can map the distribution of dark matter and gain new insights into its nature. Some key questions Webb may help answer. What is dark matter actually made of? How does dark matter shape the formation of galaxies? Could alternative theories of gravity better explain these observations? The search for extraterrestrial life, are we getting closer? The possibility of discovering life beyond Earth has fascinated scientists and the public for decades. While Webb is not designed to directly detect alien life, it plays a critical role in identifying planets that may be habitable. Upcoming missions will complement Webb's discoveries. The Nancy Grace Roman Space Telescope, launching in the late 2020s, will provide a wider field of view, detecting even more exoplanets. The European Extremely Large Telescope, ELT, will allow for direct imaging of exoplanets, potentially revealing surface details. Future space telescopes may be able to detect actual biosignatures, such as plant life or industrial pollution. Webb is laying the groundwork for a new era in astrobiology, bringing us closer than ever to finding another Earth. The expanding universe, dark energy and the fate of the cosmos. Another major mystery in cosmology is dark energy, the force driving the accelerated expansion of the universe. Webb is helping scientists measure the rate at which galaxies move apart over cosmic time, the influence of dark energy on cosmic structures, possible changes in the fundamental laws of physics over time. By studying ancient galaxies and distant supernovae, Webb may provide clues about the ultimate fate of the universe, whether it will expand forever, slow down, or collapse in a big crunch. Conclusion: a new era of discovery. The James Webb Space Telescope has already transformed our understanding of the cosmos, and its most profound discoveries may still be ahead. From detecting the first stars and galaxies to exploring potentially habitable worlds, Webb is helping us answer some of humanity's deepest questions.